Welcome back to the Deep Dive. This is where we break down complex topics, giving you the key insights without the heavy lifting.
That's the plan.
Today, our focus is on the 9th issue of Thinking in Public, that bi-weekly Substack newsletter from Alperen.
Yeah, it's got some really interesting stuff this time.
Absolutely. Our mission is to unpack the most important bits from this issue. The latest on using AI, making it work better, and what's happening in the industry.
It's a good mix.
We'll touch on how these AI models actually seem to think, some really practical tips for your prompts, and even a bit of a reality check from Apple. Should be fascinating.
Definitely. It covers that ground between the theory of AI and how you actually use it day to day. Practical tips, but also that critical look at where things really stand.
Okay, let's get started then. We all interact with these large language models, LLMs, pretty much daily, right? ChatGPT, DeepSeek, Claude, Gemini.
They're everywhere.
But are they all basically the same thing with different labels? Or are there real differences? Specifically, people are talking about reasoning models.
Yeah.
What are they? What makes them special?
That's a great question. And yeah, there is a difference. It's really about how they tackle a problem. Your classic LLM, it's kind of designed to give you the most likely answer, like super fast.
Right. Predictive text on steroids.
Exactly. But a reasoning model, it takes a different path. It doesn't just jump to an answer. It actually starts this internal process. Thinking in the background, you could say.
Okay.
It breaks the problem into smaller pieces, works through the steps one by one, and then it puts together a coherent answer. It's more like how we might solve a tricky problem, you think it through.
So less instant prediction, more showing its work. Almost like at school.
That's a perfect analogy, yeah. They're actually designed to demonstrate that internal thought process. You see this with models like OpenAI's O1 and O3 Mini, DeepSeek's R1, and Anthropic's newer Claude 3.7 Sonnet. So if you give them a long math problem, for example, a classic model might try to guess, maybe skip steps, maybe even get it wrong.
Right.
But a reasoning model will try to solve it step by step. It builds what people call a chain of thoughts, and that usually means more accurate answers, and you can actually see how it got there.
Okay, that makes a lot more sense. It sounds built for depth.
Yep.
How do they even learn to do that? Is the training different?
Yeah, the training is absolutely key. Reasoning models get trained with specific examples that teach them this step-by-step approach. And crucially, they get rewarded not just for the final answer being right, but also for getting the intermediate steps correct along the way. And that kind of detailed training makes them really good at things like, complex math, writing tricky code, logic puzzles, anything that needs careful step-by-step analysis, really.
Right. Okay, so this is where it gets practical for us. How does this change how we should prompt them? Do we still need to spell everything out, like solve this step by step?
That's the interesting part and maybe the core insight here. It's not just what they are, but how it changes your whole approach. You shift from telling the AI how to think to basically letting it think for itself. With these models, your prompt can often be much simpler.
Really?
Yeah. You just state what you want clearly. The model is already built to start that internal thinking process. It'll give you the detailed answer without needing that explicit step-by-step command.
Wow, okay. So it kind of takes some of that prompt engineering pressure off the user.
It does, yeah. It shifts the burden a bit.
But I'm guessing there have to be trade-offs, right? It can't be all upside.
Oh, definitely. Reasoning models tend to give longer, more detailed outputs. That usually means they're a bit slower.
Okay.
And depending on how you're paying for usage, potentially more expensive too.
Right, more computation.
Exactly. But for those really complex multi-stage tasks, or anything needing deep analysis like drafting a detailed report, figuring out a big chunk of code, complex planning, they offer way more help than the classic models.
But for quick stuff?
For quick answers, simple text generation, just needing something concise. Classic models are still great, often faster and more efficient for those jobs.
So bottom line, for the listener trying to choose, what's the key takeaway?
I'd say, if your task is complicated, long, needs that deep dive analysis, go for a reasoning model. Keep your prompt simple and clear. Trust it to do its thing. But for the everyday, faster, simpler tasks, stick with the classic models. Knowing this difference really lets you pick the right tool for the job each time, optimizes your whole workflow.
That distinction is super helpful.
Oh.
Okay, let's switch gears a bit. Let's talk about something that gives us, the users, even more control over the output. Understanding how AI models actually pick the next word.
Ah, yes. Temperature and top up.
Exactly. These two settings seem really powerful, but honestly, they can be a bit confusing.
Yeah.
How do temperature and topwood really work to shape what the AI says?
Right. So at its core, an LLM is always asking itself, based on everything I've learned, what's the most likely word to come next? It does this over and over for every single word. Temperature and top are basically the knobs you can turn to influence that decision-making process.
Let's start with temperature. I feel like people hear that term more often.
Yeah, temperature basically controls the randomness, or you could maybe call it creativity of the word choice.
Okay.
If you set temperature really low, like close to 0, the model will almost always pick the single most statistically probable word. The output becomes very predictable, very deterministic.
Right. Same input, same output.
Pretty much. But as you increase the temperature, say, towards 1 or even higher, you start giving less likely words a chance to be picked.
Ah.
This brings in more variety, maybe unexpected phrasing, a bit more creative flair. It's like telling a model, go on, take a little risk.
Okay, that makes sense. Randomness equals potential creativity. Now, top P, that one feels more technical. Nucleus sampling?
Yeah, top-eve or nucleus sampling. It works by creating a core group or pool of possible words. So imagine the AI has ranked all possible next words from most likely to least likely. Top-Pack tells the model, okay, start from the top of that list and keep adding words until their combined probability reaches a certain threshold, let's say 80% or 0.8.
Right.
Only the words that made it into that nucleus before hitting the threshold are even considered for the next word. All the really unlikely ones just get ignored completely.
Got it. So if I'm following, temperature affects the style of the choice, safe or risky, while top limits the options that even gets to choose from. Is that roughly right?
That's a really good way to think about it, yeah. Temperature is how it chooses from the available options. Top decides which options are available in the first place by chopping off the tail end of low probability words.
Okay.
Let's use that example from the newsletter, the sauce startup one. The prompt starts. The most important strategy for growing a sauce startup is.
Right.
So maybe the model thinks the top word choices are customers with the 41% probability, then marketing, 26%, automation, 15%, product, 9%, and network, 4%.
Okay, makes sense.
Now, if your top is set to 0.8 or 80%, it looks at customers, 41%, plus marketing, 26%, plus automation, 15%. That adds up to 82%, so it stops there. Only those 3 words, customers, marketing, automation, are in the pool. Product and network are out.
Ah.
If top was 1, they'd all be considered. If it was, say, 0.5, only customers would likely make the cut, maybe marketing, depending on exact numbers.
Okay, so top makes the list.
Right. And then temperature comes into play to pick from that list. Low temperature might always pick customers from our 0.8 pool. High temperature might randomly choose automation or marketing sometimes, even if customers was initially ranked higher.
That clarifies it so much, the interplay between the two. For someone just starting to think beyond the basic prompt, this opens up a lot. How do we actually use these together? Like, what combinations get you different results?
Yeah, it definitely adds another layer to prompting. Often just tweaking one setting is enough, but you can fine-tune with both. So, for example, if you want creative, maybe fun answers, you'd probably push the temperature up a bit, maybe 0.7 to 0.9, and keep top fairly high too, like 0.8 to 0.95, to allow a good range of options.
Okay, and for, like, factual, safe answers?
For that, you'd go the other way. Low temperature, maybe 0.3 or so, and lower top is maybe 0.5 to 0.7. Keeps it focused and predictable.
Makes sense.
For really technical stuff or legal documents, people often use settings like temperature 0.3, top P 0.4, very constrained. But a little warning, setting both too low can sometimes make the model repeat itself or give really short, unhelpful answers.
Good tip. What about something like blog post ideas?
For brainstorming, like blog posts or social media stuff, you generally want more variety. So maybe temperature around 0.7 or 0.8 and top around 0.9 encourages more diverse ideas.
So recapping, temperature is about variety, top is about how many choices get considered in the first place.
Exactly. Together, they give you really fine-grained control over the AI's output style and content. It's about balancing confidence and exploration. And honestly, the best way to get a feel for this is to try it. Go to the OpenAI platform's Playground tab, pick a model, and just play with those sliders. See what happens. It really builds intuition fast.
Great advice. Experimentation is key. Okay, moving on, let's talk about a big update for people who build or heavily use custom GPTs. This seems like a long-awaited one. Finally being able to choose pretty much any model on ChatGPT when you make a custom GPT. Why is this such a big deal?
Oh, this is huge. Especially if you're someone who really integrates AI into your workflow, building specific tools.
Right.
So when custom GPTs first came out, late 2023, it was super exciting, right? Build your own chatbot for specific tasks, upload files, give it custom instructions.
Lots of potential.
But there was this major limitation. For ages, you were basically stuck using just one or two models, mostly GPT-4o, inside those custom builds.
I see.
Which really held them back because different tasks work better with different models. You know, some are better at coding, some at analysis, some faster, and you couldn't always pick the best one for your custom bot's job.
So this update basically unlocks all that tailored potential.
Absolutely. It's a dramatic improvement. Now, when you build or edit a custom GPT, you get access to a much wider range. GPT-4o, O3, O4 Mini, GPT 4.5, 4.1, others.
Wow.
The system even suggests a model it thinks is best when you start, but you can change it whenever you want.
That's much more flexible.
It is. There's one small catch right now. If your GPT uses actions, which means it calls external APIs or browses the web, the model choices are still a bit limited, but the expectation is that'll open up soon too.
And who gets this now?
It's live for Pro, Plus, and Team users already. Enterprise and EDU users should get it soon.
So for the power users, the builders, the automators, this is a really significant step up.
Yeah, I've seen people call it the most useful update since custom GPTs launched. If you build bots, automate repetitive tasks, set up specific workflows, this just makes custom GPTs way more versatile and genuinely powerful for real-world use.
That sounds like a definite win for making these tools more practical. Okay, but speaking of AI capabilities and what they can really do, there's this recent paper from Apple that's kind of stirring the pot.
Yes, the illusion of thinking.
That's the one. It basically argues that even the smartest AI models today, well, they might look smart, but we're really not that far along when it comes to actual thinking. What's the core idea here?
Yeah, this paper really landed as a reality check in the AI world. Apple's main point is that even the advanced LLMs, including the ones we just talked about, the reasoning models, still fundamentally struggle with complex, multi-step thought. They argue that what looks like reasoning is often just incredibly sophisticated pattern matching, not genuine problem-solving ability.
So more mimicry than actual thought.
That's the gist of their argument. And yeah, it caused quite a stir. Lots of debate online. Is the AI hype fading? Is Apple just taking shots because maybe they're perceived as a bit behind in the LLM game?
Always the intrigue. How did Apple actually test this? What was their method?
They were pretty rigorous. They took some of those popular reasoning models, specifically OpenAI's O3 Mini, DeepSeek R1, and Claude 3.7 Sonnet, and tested them on 4 classic logic puzzles.
Okay.
Things like the Tower of Hanoi, checkers jumping, river crossing puzzles, block swirled. These are puzzles that you can make progressively harder. They require planning, keeping track of steps, logical deduction.
Right. Things that seem easy for humans but might be hard for pattern matching.
Exactly. By scaling the difficulty, they could see exactly where the models started to break down.
And what did they find? What were the key results?
The results were pretty eye-opening on the easy versions of the puzzles. Surprisingly, regular LLMs actually did better than the specialized reasoning models sometimes.
Huh. Interesting.
On the medium difficulty levels, the reasoning models did start to show their edge. Their specialized training helped a bit.
Okay, so some benefit there.
But here's the kicker. On the high difficulty levels, all the models, regular and reasoning, just completely failed. They couldn't solve the complex versions.
Wow. Flat out failed.
Yep. Which led Apple to their main conclusion. Current LLMs, despite appearances, can't truly think in the way we often imagine. They're not yet the smart, adaptable problem solvers capable of abstract reasoning and complex planning that maybe the hype suggests.
And sobering.
Yeah.
Especially with how human-like the outputs can seem sometimes.
Yeah.
It really highlights that gap between fluency and actual intelligence.
It does. And it's important to take this in stride, right? The field is moving incredibly fast. It's hard to predict where the next breakthrough will come from.
True.
So the takeaway isn't really despair, it's more perspective. Stay calm, don't get swept away by the hype, but also don't get overly pessimistic about the limitations. Just keep observing. This kind of research helps guide the field towards building true intelligence, not just better mimics, and it helps us set realistic expectations. It's still a really exciting space.
Absolutely. Wow. Okay, we've covered a lot of ground from this issue. We started with understanding what makes reasoning models different, that whole chain of thought idea, and how it simplifies prompting for complex tasks.
Yeah.
Then we got practical with temperature and top-up, those knobs that let you fine-tune AI responses for creativity or precision.
Right, the control levers.
We also celebrated that big update for custom GPTs, giving users much more choice over the underlying models, which is huge for practical application.
Definitely a big win there.
And finally, we got that dose of reality from Apple's Illusion of Thinking paper, reminding us that true AI reasoning is still a work in progress.
Yeah, a good balance of progress and perspective.
It really makes you think about how you interact with these tools day to day.
It does, and maybe that leads to a final thought to leave our listeners with. Given everything we've discussed, the rapid progress, the new controls, but also these fundamental limitations that Apple highlighted, how do we best manage our expectations? How do we balance what AI can do now with what we hope it will do? And what does thinking even mean for an AI, really? How is our understanding of that going to keep changing as this field continues to evolve so quickly?